Imagine a world where you can fly over traffic, reach your destination in a matter of minutes, and forget about being trapped on the road for hours on end. Sounds like a fantasy? Well, the future is here. From cars that fly to taxis that hover above ground, these astonishing vehicles are set to transform travel as we know it. Stick around, this is something you don't want to miss. Rector claims to have created the world's first flying scooter quadcopter, the Skyrider X1, which integrates ground and air mobility into a single compact device. The quadcopter can fly at a maximum speed of 214 kilometers per hour, while its ground speed is 100 kilometers per hour, and it boasts of 40 minutes of flight time on one charge. Users can enjoy hands-free flying thanks to the autonomous navigation system's route planning, obstacle avoidance, automatic takeoff and landing features. The core focus of the design is safety, with emergency parachute deployment in case of system failure and a motor system redundancy for stable flight. The X1's structure allows it to be folded and thus makes it lightweight and portable, as well as suitable for intuitive user control, which aids novice and experienced users alike. Aimed at tech enthusiasts and city commuters, the quadcopter is priced at $60,000. While there is positive early feedback on the versatility of this device, there are also complaints about the limitations in payload capacity and the noise it emits, 85 decibels at 10 meters. In future models, Rector aims to replace the motors with quieter ones and improve the battery to reduce the noise. The Jetson 1, a personal eVTOL scooter that is marketed as a flying motorcycle, has been garnering global interest. The Jetson 1 is manufactured by Jetson AB, a firm from Sweden. The vehicle has an astonishing weight of 115 kilograms thanks to its carbon fiber parts and aluminum body. This allows the craft to achieve a cruising altitude of 102 kilometers per hour for 20 minutes. Supplied with a 4-axis joystick, the Jetson 1 does not require a formal flight certificate as it is classified as an ultralight vehicle by the FAA Part 103. It is powered by 8 electric motors, each providing thrust separately. As a result, even with several motors failing, the Jetson 1 is able to safely land. The claim that the onboarding time for users' cabin is under 5 minutes helps Jetson 1 appeal to customers around the world. With the expected market price of $92,000 and deposit of $22,000 being the lowest, the demand for the Jetson 1 is anticipated to skyrocket. Because of these costs, the aircraft primarily caters to rich enthusiasts and leisure travelers, but has the potential to support recreational aviation activities. Xpeng Aero HT has recently unveiled the dual-mode flying car known as the Xpeng X3. This flying car prototype has a weight of 1,936 kilograms and features 8 rotors capable of VTOL, vertical takeoff and landing. Additionally, this flying vehicle can conveniently switch between flying and driving modes. A quad-rotor system with vertical flight capability is mounted on this vehicle and is powered by a 160-kilowatt 400-volt battery. The vehicle can be moved in horizontal direction with a combination of a control stick and a steering wheel at a maximum speed of 130 kilometers per hour. This enables the flying vehicle to remain in an airborne position for about 35 minutes, which is optimal for city travel. The upper fuselage of the vehicle can be charged by the ground chassis through inductive charging, allowing the aircraft to recharge quickly. The passengers are located in a cabin fitted with 270-degree augmented reality glass that enables precise navigation through automatic data integration on the direction and altitude. Besides, the car features triple redundant flight controllers, as well as real-time rotor health monitoring, which enables it to stand above the competition. Kawasaki presented the K-Racer X2 model in 2024, which features larger rotors for higher lift. This increase in payload capacity enabled the new model to reach 200 kilograms. The self-power artificial arms allow for a myriad of complex tasks, such as automated loading and unloading these drones. These AI-powered arms are able to scan the vicinity for obstacles, change the route in accordance to the weather, or change their movements in real time. Remote operation is currently required for these models, but full autonomy is expected in the near future. EHang 216S. The EHang, a Chinese company, has developed an autonomous aerial vehicle named 216S, which is a competitor in the emerging market of urban air mobility. It combines drone and passenger transport technologies. The 216S works as an electric drone taxi, which has 2 seats and is powered by a 21.6 kilowatt-hour lithium battery. This battery allows the drone to travel at a maximum speed of 130 kilometers per hour at an altitude of 3,000 meters. However, for safety purposes, flying in the cities is controlled to 500 meters. There is no effort required from passengers because an AI governs the most efficient routes to the needed locations in the requested order through an easy-to-use touchscreen. EHang's extensive test and training program, which has been conducted in Vienna and Guangzhou, China, includes over 3,000 test flights with hundreds of passengers. The drone taxi is designed to interface with other forms of public transportation, and work is underway to integrate it into existing transport hubs. Unlike city helicopters, EHang is pleased to claim that the disturbance level of the 216E drone taxi is 60 decibels at a distance of 50 meters, claiming it is more quiet. EHang intends to use these drone taxis in dense urban locations. Kawasaki's K-Racer X1 drone is poised to revolutionize the cargo logistics industry with its vertical takeoff and landing capabilities and fusion of technology from other fields, such as robotics, aerospace, and motorcycles. These drones use an automobile-grade supercharger lift engine from the Ninja H2R motorcycle, which supplies a whopping 310 horsepower, and weightless tail pylon systems allow for the use of 4 rotating blades. Consequently, the advanced power plant combined with 4 tilting rotors allow for a payload capacity of 100 kilograms, a flight speed of 140 kilometers per hour, and a range of over 100 kilometers. The PAL-V Liberty, the world's first commercially available hybrid car gyrocopter, makes PAL-V a contender in the mobility realm and aviation industry. Equipped with the world's first proprietary 230 horsepower engine, the Liberty can both drive on the freeway at a speed of 160 kilometers per hour and fly at a speed of 180 kilometers per hour. This means the Liberty has a driving range of 1,300 kilometers and an aerial range of 500 kilometers. The switching time from driving to flying mode is 5 minutes. The combustion engine allows PAL-V to comply with the existing aviation and automobile regulations, therefore minimizing the certification issues electric VTOLs face. The company is seeking to obtain delivery ESA approval by late 2024. In underdeveloped infrastructure areas, the Freedom model is sold for £300,000 to £800,000, providing unmatched flexibility in those regions. This design feature is extremely beneficial because it allows a safer form of auto-rotation helicopter landings when the engine fails compared to other types. Hanging monorail trains in Japan. The suspended monorails of Japan are some of the most unique rail lines in the country. Unlike regular monorails, which provide a single column for support, these suspended version can be viewed in an aerial position above the ground. This is particularly beneficial for the tourism sector. These trains also support passenger transport in developed regions. These trains allow for public and private investment to infrastructure in densely populated metropolitan locations, which greatly improves the economy. Moreover, these trains can achieve between 60 and 80 kilometers an hour, and in some instances, due to better aerodynamics, even up to 60 miles an hour. Economically, the suspended monorails can be considered efficient since they are capable of transporting 300 passengers at a time. Knowing this, the operating costs are lower. Because of the tremors in the ground, this type of monorail is considered safe for regions prone to seismic activity as it has a unique shock-absorbing system. Aeromobile, a Slovak company, is in the process of making a flying car a reality with the Aeromobile 3.0, a hybrid that works on both the road and in the air. The vehicle's Rotax 912 engine, boasting 100 horsepower, allows it to reach speeds of 200 km per hour while in the air and 160 km per hour on the road. It is capable of transforming from a car into an airplane in less than 3 minutes, utilizing a small airstrip for takeoff and landing. With a range of 700 kilometers, the aeromobile also works well for those who commute and need to bypass heavy traffic. The cockpit is engineered for 2 people and is equipped with aviation-grade aircraft instruments and simplified controls for ease of use to any licensed pilot. To ensure maximum safety, the company has incorporated a ballistic parachute along with reinforced carbon fiber construction. The aeromobile comes with an estimated price of $1.5 million, targeting high net worth individuals, and is expected to start delivering by 2026. Aeromobile 3.0 is a considerable advancement in the pursuit of real personal air mobility. With the collaboration of Uber, Hyundai is enhancing electric air taxis to ease the load of over-air traffic in cities. These vehicles avoid traffic with their ability to take off and land vertically. Recently, partners included Uber as well as Japan's National Institute of Maritime, Port and Airport Technology to bring to life a modern prototype with 6 dual-axis rotor engines housed in a sleek hexagonal pod. This machine is able to soar to an amazing 600 meters as well as outpace to 300 km per hour. This is accomplished by the vertical takeoff and rotors transitioning to forward propulsion. This is more than enough range for rides from Gangnam District to Incheon Airport. Hyundai engineers are rest assured with enhanced safety features, including extra battery power, extensive crash detection systems, and a parachute that is deployable in cases of drive power failure. By integrating lithium-sulfur batteries within a lightweight composite structure, Hyundai can improve overall efficiency by reducing the weight of the vehicle by an additional 30% compared to previous model revisions.